Hello, this is an introduction to scatterplots for AP Statistics. A scatterplot is what happens when we take a set of ordered pairs and we put it on a coordinate plane. For statistics, what we are trying to do is we're trying to decide if there's potentially a relationship between these two variables. If they increase together, if they decrease together, if there's no predictable relationship. So plotting them on a scatterplot can really help. In this particular scatterplot that we have over here, you can see that there are two variables, hours of study and test scores. Okay, and so we have one variable on each axis, and then each one of these dots represents one observation. So we went up to one individual and collected two pieces of information from that one individual. And we said, how many hours did you study? And then what was your test score? So in this case, there are 18 dots, so we can tell that there were 18 individuals that were asked these two questions. Remember, the variable is the question that was asked. So we can tell because there are 18 dots, there was a sample size of 18. Okay, so the sample size is the number of individuals, not the number of numbers. Okay, so we actually collected 36 numbers, but each set of ordered pair, each set of data belongs to one individual. Right, so vocabulary here, the variable on the x-axis is called the explanatory variable, and the variable on the y-axis is called the response variable. Now, for right now, this is something that you can just memorize. We're going to be using this quite a bit in Chapter 2 when we talk about experiment design. But in this case, the explanatory variable is the one on the x-axis. Okay, and that's the one that we're trying to use to explain what's happening with the response variable. So we think there might be a relationship between how many hours you study and your test score. And so we're saying as X changes, as the hours of study increases, what seems to be happening to test scores? Can we use hours of study to explain what's happening to test scores? Okay, so a lot of times we're going to have this statement, what is the effect of the explanatory variable on the response variable? What is the effect of hours of study on test scores? Now, to describe what we see in a scatter plot, like this one up here in the right-hand corner of your notes, we're going to use 4 things. It's kind of like socks, but it's for scatter plots. So we're going to be talking about form, strength, direction, and anything unusual. Okay, so form is the shape. Form, basically we're saying, does this data look linear? Does it look kind of line-like? Does it look nonlinear? Is it a curve, like a parabola or an exponential graph? Or is there no meaningful pattern, no meaningful relationship? Strength tells us how predictable the pattern is. A strong pattern means you have a very strong inclination about where those points are going, and you feel like you could make predictions. Weak means that there's a pattern there, but not very, it's pretty scattered. There's not a lot of predictability in what's going on. And then direction, if it is linear, we like to say what's happening as X increases, or what kind of slope would this have? So if we're talking about the rise over run of the line of best fit that would run through this, is it going to be positive or negative? There is a phrase that you're going to want big time for weaseling in this chapter. It's the word tends to. So a positive slope is one where as X increases, Y tends to increase as well. As X increases, Y tends to decrease as well. So I'm going to go back up to my picture up here in the corner. So what I notice is that this might be curving slightly, but for the most part, I think that this looks fairly linear. Okay, so I think that it seems to be following sort of a line-like pattern, although you might argue that it is doing some sort of curve here. It's relatively strong, and it looks like it's positive. As X increases, as hours of study increases, it looks like Y tends to increase as well. Now, again, the reason why we use the word tends to instead of just as X increases, Y increases is because this is not a straight line. And when I look at, say, these 2 points right here, the one on the right has a bigger X value but a smaller Y value. So that's a case where as X increases, Y didn't increase. So we're talking about an overall behavior, a tends to, rather than just the value there. So again, in this example, if I was asked to describe, I would say there is a strong, positive, linear relationship. So here's my form, linear. Here's my direction, positive. Here's my strength, strong, between hours of study and test scores. So I'm always going to write my X variable and my Y variable in context to describe that relationship. Okay. Now, another thing we tend to look for is anything unusual, points that don't fit the pattern. And we're going to talk about those more in section 5.3. But we want to identify things that don't look like they fit the pattern of the points. Does it not seem to follow? Is it way out there to the side? Is it way out there above or below? Is there a cluster? Is there a gap? We always want to look out for things that seem interesting. All right. Now, big word of caution. Just because two variables seem to have a relationship doesn't mean that one variable is causing the other one to change. Okay, so in our case, just because it looks like the more hours you study, the higher your test grade would be, does not mean that the hours of study are causing the test scores to be higher. Okay, we have to be very careful about the way we word that. There could be some other underlying thing there, that people who studied for longer maybe also did more homework. Or people who studied for longer, maybe they have a better understanding or something like that. I mean, there could be something else going on there. Okay, so in our first page, again, just because we see that hours of study increases, test scores tend to increase as well. That doesn't mean that one is causing the other to rise. It could be true, could be, okay? But when we talk about a predictable relationship, we're not talking about cause and effect. Okay, so these are not cause and effect graph. This is increasing because the other thing is increasing or decreasing. We're just talking about a relationship that can help us to make predictions. Okay, and just to kind of illustrate this a little bit, there is a guy named Tyler Vegan who has a whole study of these relationships that have a very strong correlation, but they don't actually have anything to do. So this is the number of people who drowned by falling in a pool, followed by the films Nicolas Cage appeared in each year. Okay, so you can see that these two things seem to correlate very well. There seems to be a very strong relationship, but that doesn't mean that as the number of people who drown in a pool increases, that Nicolas Cage gets to be in more movies. Okay, here's another one. This is the divorce rate in Maine and the per capita consumption of margarine, right? Like, I can't believe it wasn't butter, right? I mean, like, the butter is not causing margarine's not causing the divorce rate to fall or rise for each of these years. So sometimes you'll see relationships between two things, and just because there's a relationship does not mean there's any sort of cause happening there. All right. So if you were going to describe each of these scatter plots, again, we're looking for that direction, unusual, form, and strength. So I'm going to take a look at this, and let's see. It looks like this is, in general, increasing here. I've got my two variables, so I'm going to type into this blank. I'm going to say there is a strong, because it looks pretty predictable. If I went over to 97 or 98, I'd have a pretty good idea of what's going on there. A strong, positive, because the slope of that line is positive, linear relationship. Oh, I can't spell relationship. Woo. Between between average daily temperature and number of visitors. There's a strong positive linear relationship between my two variables. Over here, I look at this, I've got IQ and shoe size. I don't think this is positive or negative. That just seems to be very randomly scattered. So I'm just going to say there is no relationship. Or actually, I'm going to throw in another word. There's no meaningful relationship here. Relationship between shoe size and IQ. So I cannot tell based on your shoe size whether or not you will be more or less intelligent. All right, number of missed classes and exam score. Okay, so again, I look sort of like a negative line here. Okay, so I would say there is and that's fairly predictable, strong, negative, linear relationship between number of missed classes and exam score. Okay, and then over here, wow. Now this looks to me like a parabola, like very, very strong. But I mean, so it's definitely, there's a strong something happening here, but it is not a line. Okay, so I'm going to say there is a strong, non-linear, if you want to, you could say curved, relationship between hours studied and test score. Okay, so notice that I didn't say positive or negative because this is curved, and so if something's linear, it's going to have slope, but otherwise we're not going to describe that. Now, you could say something like the scores increase until about 12 hours and then they start to decrease, but that is a non-linear relationship here. Okay, now here is another kind of interesting thing. It does look like it's generally positive, but it doesn't look very strong. Also, it almost appears like we've got two clusters of points here, so I might mention that. So there is okay, so definitely not strong. So I'm going to say weak, positive, linear relationship between waiting times and eruption time. Okay. I'm going to also say it appears there are two clusters of points, one from 0 to 70 minutes and waiting time, and a second from 70 to 90 minutes waiting time. And I just started to write minutes, but that doesn't work because the other axis is also measured in minutes, so I have to be a little bit more specific. Okay, now this next point, I've got a definitely negative. It's very strong, but then there's like, what in the world is going on right here? Okay, so that guy right there, that is an unusual point that I'd want to mention. Okay, so there is a strong negative relationship between, oh, and there's no variables here, so I'm just going to mention x. I'm going to say the explanatory variable and the response variable. Okay, I really want context on those, but I don't have any, so I'm going to use this instead. Also, there appears to be an outlier at about 1.5, 1.5. So I don't know specifically if there's going to, what these variables are or what that's, and we're going to talk more about outliers later, but that point just doesn't seem to fit the pattern. All right, so I'm going to describe those. Oh, and I just flipped that over. That's exciting. Okay, now to use your TI-Nspire to make a scatter plot, you're going to do the same thing you did with one variable data in that you're going to put everything in a list, but now you're going to write them as ordered pairs in two lists. Okay, now here's an example of kind of what I've done on your paper so you can follow along. Okay, so you're going to make a list with X and a list with Y. Okay, and your list and spreadsheet. And then you'll add that new data and statistics page. On the X axis, you will click and add your X variable. And then on your Y axis, you will click and add your Y variable. That's going to give you this delightful little scatter plot. And then if I wanted to transfer this onto my paper, I would just mimic the scale that was given to me. And then I would literally just plot the points. Okay, so down here to transfer that onto my paper, I would mimic the scale. I'd make sure I labeled my both axes here. And then I would take my points from my original data set like I would have done without my TI and plot the points where I was there. Okay, so it's a really quick way in order to do that. All right, so here we have an example, and it says, a survey was conducted in the United States and 10 countries in Western Europe to determine the percentage of teenagers who had used marijuana and other drugs. The results are summarized in the table. Countries are used for identification purposes only. All right, so this is something that some people have been having struggle for. If I have this country over here, so the Czech Republic, for example, in this example, I've got marijuana and other drugs. This up here is an ordered pair that we're going to look at Once I've got that ordered pair graphed, I don't need that name. That name doesn't need to go on my graph anymore. Okay, so when we're talking about numerical data, the identifier for who that is not important any longer in our analysis of the data. We still have that recorded. We might use that later. There was an example about using Boardwalk and Park Place and their prices. I don't need to include the words Boardwalk and Park Place anywhere on my graph. Okay, I'm just looking at the numerical data. Okay, so it says, who are the individuals in the study? So the individuals are the people we went and asked the questions. Okay, so in this case, the individuals are going to be the countries. And there are 10 of these countries plus the United States. So there are 11 countries. So that gives me a sample size of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It says, what are the variables that were measured for each individual? Okay, so one thing I want to be careful at, because it's really tempting here to write that my variables are marijuana and other drugs, but that's not a variable. A variable is not marijuana. That's not a variable. It has to be a question that you've asked. So this one, the first one, we can say percent who have tried marijuana and percent who have tried other drugs. Okay, so we want to be careful. You don't just say marijuana and other drugs, because those are not variables. Those are just words, okay? So a variable has to imply that that could be changing depend on who you ask. It says construct a scatter plot in the space below and then describe the scatter plot. Okay, so I'm going to pause the video here and I'm going to open up my TI-Nspire. Okay, actually, hold on. Here's my TI-Nspire. I'm going to add a list and spreadsheet here. And I'm going to put an M for marijuana and an O for other drugs. And I'm going to type in, so list and spreadsheet, I'm going to type in these values. So like the first one, it goes 22 and 17 and 40, and this one is 4 and 3 and 21. And I'm going to type those in. So I'm going to pause the video. I'm going to type this data in. Okay, so I have taken this data and I have typed it in. So I have all of my percent who tried marijuana numbers in the first column and all of my percent who've tried other drugs in the other column here. Okay, so I got those off of the table. Okay, notice I have them labeled. Okay, the next thing I'm going to do is I'm going to create a new page. So I'm going to press Control and Dock to get a new page. And we want a data and statistics page. All right, I'm going to take my cursor down here. I'm going to click to add my variable. I'm going to put marijuana. That's my x-axis. And I'm going to click up here and I'm going to put, oh, there's the other drugs. And now I've got my other axis here. So notice that the graph goes 5, 10, 15, 20, 25, 30, etc. Goes by 5s from 5 up to 55. And the other direction, it's going from 0 and it's going by 8s up to 32. So I'm just going to mimic that on my paper. So from 5 up to 55 and then from 0 up to 32 by 8s. Okay, so I'm going to take my handy dandy pen here. All right, so I'm going to draw this axis. Okay, and I've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, okay? And this is going to label the percent who've tried marijuana. And then I'm going to go the other direction, and it went by 8s up to 32. So 8, 16, 24, and 32. And this is my percent who've tried other drugs. Okay, so I've got those two labeled. I've got my axes. I just copied them pretty much straight off of that. And now I'm not going to go back to my calculator for this because I've got this data. So my first point here was 22 and 4. Okay, so I'm just going to zoom out so I can see all of this at once. So that 22 and 4, I'm just going to plot that where that would be. So here's 20, 22 and 4, and 17 and 3. Okay, so I'm just going to plot these points where they would go. 40 and 21 and 5 and 1 and 37, etc. All right, so I'm going to pause again and finish plotting those. Okay, so I've transferred all of my points over here, and you can see that I made my points kind of messy. Sorry, hard to draw on the screen. Hopefully yours are better. It does kind of have this appearance of the graph that was on our calculator here. And if I was going to describe this, then I would say it looks like there is a strong, positive, linear relationship between the percent who have tried marijuana and the percent who have tried other drugs. Okay, I don't see anything unusual here. And so it does seem to be that as the percentage in a country who tried marijuana tends to be higher, that the percent of tried other drugs also seems to be higher. And so a politician claims in an interview that marijuana is a gateway drug, meaning that marijuana use leads to the use of other drugs. So what they're saying is, if a person uses marijuana, they think, okay, marijuana is not that harmful or whatever. Does that make a person more likely to try other drugs? So does using marijuana cause people to use other drugs? Does your scatter plot provide evidence to support this statement? Why or why not? So remember, our scatter plot shows that there seems to be a relationship in countries between a high percentage of marijuana users and the percentage of other drug users seems to be high as well. And then low and low. Does that mean that marijuana causes that? And no, it doesn't. Okay, so we would say something like no, so that although as the percentage of marijuana, percentage who have tried marijuana tends to increase or sorry, maybe we should say larger values. Okay, so although large values of the percent who tried marijuana tend to be paired with large values of I can't type. Percentage who have tried other drugs. This does not show causation. This does not mean that trying marijuana causes individuals to try other drugs. So the important thing to remember is just because you see relationships between two values does not mean that one relationship is causing the others. Okay, so what do you need to know? You need to know how to describe a scatter plot. You need to be able to talk about direction. Is it positive, negative? Form. Is it linear, non-linear, nothing at all? Strength, does it look strong? Is it weak? And we'll talk about more of that in the next section. And do you see anything unusual? Is there anything points that don't seem to fit the pattern that's going on here? And then the other thing is to understand that even if you are seeing a very strong relationship, it doesn't mean that one variable is causing the other one to change.